Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class. And today we're going to talk about collinearity, betweenness, and assumptions. Like every section of this chapter, extremely important, okay? We really got to understand these words, so please ask questions, get involved in the lecture, let me know what you're thinking. Let's first look at the first word here of our title of this section, collinearity. Think about the roots here, guys. We have line in there and co. Okay? Think about this. When you think of a co-ed school, what does that mean? Yes, sir. Okay, boys and girls are both together at that school, right? In the same school. Well, collinearity is very similar, but with points. Points that lie on the same line, okay, are called collinear. Points that do not lie on the same line are called non-collinear. Pretty simple. Collinear, points that are on the same line. If points are not on the same line, they're non-collinear. For example, that is red, just like the red word for collinear. I try to match them up with colors. A, B, and C are all collinear. Pretty simple. Why? Because they're on the same line. And then point F, point D, and point E, as you can see, that's in blue, matching up with non-collinear. These are points for sure, and they're on a line. That's fine. Bless you. But they are not collinear. Okay? Pretty simple concept, very important concept. Points that are on the same line are collinear. Points that are not on the same line are not. They're non-collinear. Betweenness of points. A point is between two other points if and only if all 3 points are collinear. If all 3 points are not collinear, then we cannot say that one point is between the other. I know this doesn't make a lot of sense maybe to you, but if you think about this, E, F, and G. E, F, and G here are not collinear. They're not on the same line. They're on different lines. So therefore, you cannot say that F is between, that F is between E and G. That should be an E there, my bad. F is not in between E and G. However, A, B, and C are collinear. So therefore, B is between A and C. Again, very simple concepts. And this is where a lot of my geometry students falter. They think, oh man, these lessons are so simple. I'm not going to have to do anything. These are the concepts that haunt you later when we're doing proofs, my friends. And proofs are coming up in a section. So when we start doing proofs, you have to know these terms. So please don't take this easiness for granted. Please and thank you. So again, betweenness, a point is between 2 points if and only if they're all collinear. Cool? Good stuff. Okay, next. Triangle inequality. Huge in this class. Huge on the SAT, I promise you. In any given triangle, no one side can be greater than the sum of the other 2 sides. Let's repeat that again. In any given triangle, no one side can be greater than the sum of the other 2 sides. In other words, the sum of any 2 sides of a triangle must be greater than the 3rd side. If that does not occur, then it is not a triangle, period. Okay? For example, is the figure below a triangle? Okay. It's a very easy algebraic way to set this up, my friends. Since we know that the sum of any two sides must be greater than the third side, check out the following formula. That means that 14 plus 11 has to be greater than 24. And that means that 11 plus 24 has to be greater than 14. And then that means that 24 plus 14 has to be greater than 11. 14 plus 11 is 25, so that works. 11 plus 24 is 35. It's greater than 14. That works. 24 plus 14, that's 38. That's greater than 11. That works. So in this particular case, this would be a triangle. Now, let's say that instead of this 24 here, gentlemen, I had a 30. Okay? Then this here would become a 30. And now in this particular case, is 14 plus 11 greater than 30? So if that side was 30, you would have to say not a triangle. If that was a 30. Okay? Our original one was a triangle, though. Not bad, right? Pretty simple. Yes, sir. Thank you.
What if two sides equal on another one like the exact same as one?
Okay, very good. That is a phenomenal question. The question was, what if they're equal? What if the sum of two sides is equal to the other side? It is still not a triangle. Okay, think about the nomenclature I used. Has to be greater than. Not greater than or equal to, but greater than. So that's a great question. Thank you so much. So in other words, this would not be a triangle. I had 15, 15, let's say 30. That's awesome, but that's not a triangle. That's impossible. Because 15 plus 15 is equal to 30, not greater than 30. Does that make sense? Thank you, sir. Great question. Okay, now, assumptions. Okay? There are certain things in geometry that you can assume. And there's certain things that you cannot assume. Please memorize these, learn them, absorb them, love them, live them, because this is huge, especially for proofs. Let's first talk about what you can assume. Okay, first of all, you can assume straight lines and angles. So if you see this here, like that, you can assume that's an acute angle. If you see a straight line, and that's not too straight, you can assume that's a straight line. So you can assume straight lines and angles. Okay? You can't assume, oh, that's a 32-degree acute angle. No, you can't assume that. But you can assume straight lines and angles. Number two, you can assume collinearity of points. I mean, it's pretty simple to see. If you see 3, 4, 5, 7, 20 points on the same line, you can already say, okay, these are collinear. That's a safe assumption to make. Betweenness of points. It makes sense that if you can go ahead and assume collinearity, you can go ahead and assume betweenness. Why does that make sense? Because if points are not collinear, they cannot be between. Okay, so you can assume betweenness as well. And last but not least, you can assume relative position. Point A is to the right of point C. Point D is above point E. Point A is to the left of point B, etc., etc. Now, what can't you assume? You cannot assume right angles. We already talked about this a little bit. What lets you know guaranteed that it's a right angle? Yes, sir. That's exactly perfect. That little square symbol at the end. If you don't remember what I'm talking about, if I have an angle and I have a little square here, what I just drew is not a 90-degree angle for sure. However, by me putting that little symbol on it, I don't care if it is or not. You have to accept that it is a 90-degree. But you cannot assume it, okay? You just can't assume it. The SAT gets you a lot with that. Number two, you cannot assume congruent segments, unfortunately. But, sir, they look so close. Yeah, they may look close. They may be exactly the same. You can maybe prove it with a ruler, but you cannot assume that you have congruent segments, gentlemen. Number three, you cannot assume congruent angles. We talked about tick marks already. If two angles are congruent or two segments are congruent, they're going to have equal tick marks that let you know, hey, reader, these are congruent. But you cannot assume them. And relative size of segments and angles. You can't assume that. Okay? You just can't say, oh, that's about 9 or it's a 42-degree angle. You cannot assume that. Okay? These things are really important for you to remember, so please try to do so, my brothers. So let's see some examples here. For example, okay? Given the diagram as shown, what can we assume? Okay, so I put two little columns. I put we can assume this, we can't assume the other. All right, my man, what do you got?
There's a straight line from A to B, line segment A to B.
Okay, so you can assume that ACD would make a line, or a line segment, and BCE is also a straight line. Very good. Yes, sir. Next, go for it, my man. I'm very proud of you. You cannot assume that BAC is a right angle. And you know what? Actually thinking on that logic, also you cannot assume that CDE either. So you can't assume that CDE or BAC are right angles. You just can't assume that. Excellent. All right, what else can we assume, do you think, my friends? Can't you say that angle, even though we said, okay, we could call it a line, but it's also an angle. Angle BCE, and for that matter, angle ACD are both straight lines. So we can assume that as well. Does that make sense? Okay, what else do you think we can assume? Yes, sir. Come again? You can assume, yes, that B, C, and E are collinear. Wow, very good. I didn't even catch that one. Very good. So points B, C, and E are collinear. Very excellent. What else can we assume? Yes, sir, right here in front of me. Oh, now you guys are thinking. Point C is between B and E, or you could have said point C is between A and D, because they're all three of those are collinear. What else, my brother? Yes, sir.
Just another question. Why do you call it angle BCD instead of line segment?
Because a straight line can be a straight line or a straight angle. Thank you so much. No, thank you. That's what learning's all about, brother. What else, guys? What else can we assume? A, C, and D are collinear as well. Yes, yes, yes. Okay. Yes, sir. Um, no. No, we can assume straight lines and angles, but we can't assume any other size of angles. How about this? This one's kind of tough. Again, we're training. CDE is collinear. We know that one. BCE is collinear. And how about this guy? Point E is to the right of A. Can we assume that? Absolutely. Relative position of a point you can assume. You could also say point B is above A, or point C is to the right of A, or point A is to the left of C. So there's probably a lot of other assumptions that we can make, but these are some basic assumptions that you should know. Please. Now on the can't assume side, we cannot assume that BAC is a right angle or CAD or CDE either. What else do you think we cannot assume? Sir?
We cannot assume that B is an acute angle.
You cannot assume that B is an acute angle. And for that intents and purposes, you cannot assume that angle B is congruent to angle E. Although it looks very similar, you cannot assume that CD is congruent to DE. Although I'm pretty darn sure that I'm right, you still cannot assume, oh, and I wrote the angle wrong. You cannot assume, not that CDE, but I meant to say, you cannot assume that angle BCD is obtuse. Now you may be looking at that and saying, Mr. Morrow, please, sir, that is so obtuse. That's great. It is. We can probably prove it, but you can't assume it. Why do I say that? Because I've seen questions like this on the SAT. Okay, a beautiful little triangle, and it looks like an equilateral. And I kid you not, they'll say, angle A measures 132 degrees. You're thinking to yourself, no, it doesn't. No, you're wrong. That's not 132 degrees. But you better guess what? It is, if that's the way they tell you. Okay? Geometry is about what is given, what is factual, what is there, not what we think is there. That's the beauty and the hard part about geometry. Yes, sir. Nah, that's different. Then you can prove it. Yes. But in a picture, they're going to say figures not to scale. They're not going to be exact. That's why you can't assume them. So you can either prove them or they can put a number there, and then you have to use that value. Yes, sir. Is BCD obtuse? No, you can't assume that, unfortunately. So I mean, you know that we can prove it, but you can't assume it. Okay? Thank you so much. You guys are really awesome questions. And another thing we cannot assume, look at BC and CE. Doesn't BC look longer? Yeah, that's awesome, but you can't assume it. It's crazy, I know. Assumptions mean nothing here in geometry, except you can assume a straight line. Okay? You can assume the collinearity of points, the betweenness of points, and the relative position of points. Does that make sense, my brothers? Okay. We're almost done. Let's look at a few more examples. Okay. Let's look at some sample problems. When we do sample problems, by the way, these are very similar to the homework problems. For each diagram, tell whether x is between P and Y. So for A, is x between P and Y? Abso-freaking-lutely it is. Yes. Why? Because P, X, and Y are collinear. How about B? Is x between P and Y? No, because X, P, and Y are not collinear. How about here, guys? For this angle, is x between R and P? No, unfortunately, because they're not collinear. Yes, sir. No. You'd have to have it like this, my brother. You'd have to have a point here, a point here, a point here, go like this, and then come straight down like that. And then, okay, those are collinear. Thank you so much. Great questions. Okie dokie. All right, next. Number 2. Draw a diagram in which A, B, and C are collinear, A, D, and E are collinear, and B, C, D are collinear. Or non-collinear, I'm sorry. So A, B, C are collinear, A, D, E are collinear, but B, C, and D are non-collinear. See what you can think up of. I'll give you a second here. I'll pause it. Okay, guys, check it out. It's exactly what he had said. I made a line ABC, that's collinear. Then I made a line straight up and down here, which was DAE. That means that AD and E are collinear. But B, C, and D, no, that's not collinear. Yes, sir. Great job, son. Yes, sir. I'm sorry, my man? Yeah, this line here that I did, yeah. I don't understand. So you have an A here.
So the A be at the bottom, it'd be A, then D, then E.
Oh, yeah, of course. If the D was here and the E was here, absolutely, my brother. That's still collinear. Awesome. Thank you, sir. Excellent job. Okay. Next. Use the figure below to answer the following questions, my brothers. Should we assume that S, T, and V are collinear? Yes, sir. Absolutely, yes. 100% you should. Should we assume that S is 90 degrees? No, we cannot assume that. And guess what, boys? We have now learned betweenness, collinearity, and assumptions. God bless you. I hope you had a great class, and I hope you learned a lot. Thanks a lot.